So next is classification of logic gates. As shown in the figure 4.7.1, the logic gates are classified into three categories: the basic gates, the universal gates, and the special purpose gates. So basic gates are NOT gate, AND gate, OR gate. Universal gates are NAND gate and NOR gate. Derived gates are XOR and XNOR gate. NOT gate or the inverter. The NOT gate or the inverter is a logic gate having one input A and one output Y. So it has one input A and one output Y. Its symbol and truth table is shown in the figure 4.8.1. So this is the truth table. It is an inverter gate. So if the input is 0, the output will be 1. If the input is 1, the output will be 0. And you have one input, one output. Bubbled represents inversion. So the bubble represents inversion. Important points about the NOT gate. The NOT gate is also called as an inverter because its output is the inverted version of its complement of its input. So it's the inverted version or the complement of its input. So if A is the output, then A bar is the input. So if A is the input, then A bar is the output. This is shown in the truth table of the NOT gate. The operation of the NOT gate for various input combinations is as shown. So the various input combinations, the operation will be: if A input combination is 0, output will be 1. If input combination is 1, output will be 0. Operation for pulsed input. The input to a gate may not always be in the form of a DC voltage. In certain applications, the input can be in the form of a train of rectangular pulses with their high and low levels within the prescribed limits as shown. So low level will be a 0 level, high level will be 1, 0, 0, 1, 0, 1, 1, 0. So input is, if the input is 0, my output will be 1. So here I get 1 corresponding to this 0. Corresponding to this one, I get a 0. 0, 0 give 1, 1. 1 gives 0. 0 complement gives 1 as the output. 1, 1 input, 0, 0 output. 0 input, 1 output. So exactly it is the complement. So this figure shows the timing diagram for a pulsed operation of a NOT gate. In the pulsed operation, pulse of a finite duration are applied at the gate input. These waveforms show that 0 input gate produces 1 as the output. Thus, the inversion is observed. Standard package IC gate. The NOT gate is available in the monolith integrated circuit form. IC 7404 is a 14-pin TTL integrated circuit with 66 inverters inside. Next is the AND gate. AND is one of the logic operators. It performs the logical multiplication on its input. So your AND gate performs which operation? Logical multiplication. The output is high, y equal to 1, if and only if all the inputs are higher. So output when is high? When is y equal to 1? If all the inputs are high. So if A and B is high, 1, 1, then only the output y is high. The output is low if any one of the inputs are low. So if any one is low, so if A is low, the output is low. If A and B both are low, output is low. If B is low, output is low. So if any one of the output is low, if any one of the input is low, then the output will be low. AND gate can have 2 or more inputs and only one output. So your NOT gate, that was the first gate, had only one input and it had only one output. For AND gate, you can have more than one or more inputs, but your output is only 1. Logical symbol and truth table. The logical symbol of the two input AND is as shown in figure 4.9.1. The truth table of the two input AND is shown. Note that the output is high when both the inputs are high. So if both the inputs are high, then only the output is higher. If any one input is also low, then the output will be low. And this is the symbolic representation. Boolean expression, the expression relating the inputs A and B and output Y of a gate is called as a Boolean expression. The Boolean expression of AND gate is A dot B. So this is what this operation performs: logical multiplication. Standard package IC gate. The AND gate is available in the monolith integrated circuit form. IC 7408 is a 14-pin TTL integrated circuit with 4 AND gates inside. It is therefore called as a quad AND gate IC. So next is the OR gate. The OR gate performs logical addition. On its input, therefore its output will be high if any one of the inputs is also higher. So if you have 1 0, output will be 1. If you have 0 1, output will be 1. If you have 1 1, output will be 1. So even if any one of the inputs is high, output has to be higher. Its input will be low, that is 0, if both of them are 0. If it is 0 0, then the output will be 0. So if both are low, then only the output will be low. So shows the truth table of two input OR gates. Note that the output Y is low if only both of them are low. So if both are 0 0, then only the output is 0. If any one of the input is high, that means this is 1, this is 1, here both of them are 1, then the output will also be 1. Boolean equation: Y is equal to A plus B. Standard package, that is the IC gate. The OR gate is available in the monolith integrated circuit form. IC 7432 is a 14-pin TTL integrated circuit with 4 2 inputs or gate insider. Special types of gates or derived gate, that is XOR and XNOR gates, are special types of gates. These gates can be used for applications such as half adder, full adder and subtractors. These gates are also called as the derived gates. The XOR gate. The exclusive OR is abbreviated as XOR gate or sometimes X and OR gate. An XOR gate can have 2 or more than 2 input terminals and 1 output terminal. So this also has 2 or more input terminals but only 1 output terminal. So this is the 2 inputs and this is the sign for XOR gate. In the XOR gate, what happens if both the terms are like terms? That means if both the inputs are same inputs, if it is 0 and 0, then the output will be 0. If it is 1 and 1, then the output will be 0. So when both are same, output is 0. When both are different, output is 1. So both inputs are different, output is 1. The truth table of the two inputs XOR gate is shown, which shows that when both the inputs are identical, that is A equal to B, the output is low. So when A is equal to B, output is low. And when A is not equal to B, the output is 1. That is high. The Boolean expression is Y equal to A XOR B. Applications of XOR gate. Some of the applications of the XOR gate are as follows. So as a magnitude comparator in binary to gray converter, in the adder and subtractor circuits in parity generator as a modulo 2 adder. The XNOR gator. The word XNOR is a short form for exclusive NOR. The exclusive NOR means not exclusive OR. So XNOR gate is equivalent to an XOR gate followed by a NOT gate. The symbol of the two inputs XNOR gate is as shown and its truth table is given. So in case the output of an XNOR gate is high, if both the inputs are identical. So what is XNOR? XNOR is not of X or. So that's why it is written XOR gate followed by a NOT gate. We saw that in case of an XOR gate, if A was equal to B, then what was the case? You had the output as 0, that is a low output. So when you say not of X or, that means complement. When I say complement, it will be reverse. In case of XNOR gate, if A will be equal to B, then the output will be 1. So it will be reverse of the XOR gate because it is not of the XOR gate. So if the inputs are 0 and 0, that means inputs are identical, output will be 1. Inputs are 1 and 1, inputs are identical, output will be 1. If A will not be equal to B, then output will be 0. So 0 and 1 is 0 and 1 and 0 is 0. The Boolean expression is complement of A XOR B. What is XNOR? XNOR is nothing but complement of XOR. Okay, this is the representation. And what are the applications? As an even parity checker, as a comparator, and as a even parity generator and checker.